Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. And I'm back this week after a week at Automate. It was a great week, a great trade show. I had a chance to see a lot of customers, talk to a lot of automation users. And we had a chance to record a few short videos, one every day. And I want to give a shout out to Emily for doing a great job of putting those together and getting those posted on a daily basis. Also, I want to thank Casey for manning the store here and giving us a great presentation on the XL Prime last Tuesday while I was gone. And again, it's great to be back. So here's our session for today. Today, it's all about creating a UDFB from scratch using Cscape. Now, some of you may be saying, now wait a minute, I know you guys have covered this topic before. You may even have watched some of those previous videos, which is terrific. But keep in mind that this is a really important topic. So even if there's a little bit of repetition, that's okay, because any application engineer, any automation programmer, any ladder logic programmer, this is a skill you really need to have. And I want to assure you that we're not covering over all the entire same ground. I've got some new techniques and some new tricks I'm going to show you today that you should be able to take advantage of. Now, if you're watching this live on Tuesday at 2 o'clock, you can chat in your questions and we'll get those answered right away. We've got folks standing by. As a matter of fact, I believe it's Casey Gardner, our product manager, standing by to answer your questions today. If you're watching this on replay, just give us those questions in the comment section and we'll get those answered just as soon as we can. All right, let's get started. Here's the content today. We're going to talk about creating a UDFB from scratch. We're not going to go over a lot of previous ground that we've already covered, but we are going to do a quick one-slide review of UDFBs. We're going to tell you and talk about the goal of today's session. What is the information we're presenting to you today that's maybe different than the previous sessions we've covered with this topic? We are going to go through the standard UDFB creation process because that's an important topic, an important thing to kind of review with customers. Also, what is definitely new for this week and for this topic is I'm going to go through my workflow and some techniques that I use when I'm creating user-defined function blocks that are a little more complex than maybe some that have been done before. So for instance, if you are creating a UDFB that converts degrees Celsius to degrees Fahrenheit, or that calculates the number of gallons in a tank, something like that. Those are great UDFBs, but they're relatively straightforward. They have a relatively low amount of logic. So the techniques you use for those aren't quite as important as the techniques that you may need to use for a function block that has a lot of logic embedded in it. Because when you have more logic, there's more room for you to get tripped up through one of the steps. So we're going to give you the tips that you need to be able to do that effectively based on our experience and also based on the experience of some of our students in the advanced training where we spend a lot of time on user-defined function blocks. Here's our quick one-slide review of UDFBs. UDFBs stand for user-defined function blocks. These are sections of code that you modularize into a function block by a programmer so that you can reuse them over and over again in future projects. Unlike subroutines, you can use multiple instances of user-defined function blocks in the same program. That's not something you can do in a subroutine. When you create a UDFB, you create them with their own set of dedicated variables. And then when you add an instance of a UDFB in a future project, for every instance you add, there's a unique set of variables for that instance. So that means that, of course, you can have multiple instances. Again, a big difference from subroutines, for instance. And again, once UDFBs are created, they can be imported and used in any future Cscape project. That's really the power of this feature, is the fact you can take this repetitive function that you do on a regular basis, whether it's within one project or multiple projects over time, and you can have proven code that you reuse in a consistent fashion, save yourself time, and improve accuracy and organization of your code. Now keep in mind what we've got written there in red, and that is that UDFBs are not available with register-based advanced ladder. This is a feature that's only available in variable-based advanced ladder, sometimes we call it tag-based, or in our IEC 1131 implementations. So that may be one of the reasons why you decide to transition away from register-based and towards one of the other options. The goal of today's session is what we want to review next. And before we do that, let's review quickly the ground that we've previously covered in our 2 sessions on this topic. So the first time we covered UDFBs was in a webinar. It wasn't really a live stream format, and that was Introduction to UDFBs. And that's a really good session where we focused a lot on what is a UDFB, what are the advantages of a UDFB, and we released that right around the time that UDFBs were added to the Variable-Based Advanced Ladder with Cscape 9.9 Service Pack 3. So we compared UDFBs versus main loop logic versus subroutine logic, and we performed some basic demonstrations. And then about a year ago, we revisited the topic with a session called Hands-On with UDFBs. And that focused more on the process of creating the user-defined function blocks, and we demonstrated creating relatively simple UDFBs using a standard process. Okay, so those were both very worthwhile sessions. I would encourage you to go back and take a look at if you haven't done so already. However, in today's session, yes, we're going to create a UDFB from scratch like we have done in previous sessions. However, we're going to show a more advanced workflow that's appropriate in those situations where you're creating a UDFB that's a little bit more than just converting a value or calculating a volume. Something with a little more code in there where there's more room to get tripped up. We're going to show you a workflow and some tips and tricks that allows you to get that done efficiently and accurately. So that's our main focus today. Let's review the basic workflow for creating UDFBs. This is not new territory, but it's important territory. So here's our process. You always start by writing and testing the logic that's going to be included in the function block on a standalone basis. Whether you start with a blank slate or whether you copy and paste logic in from a different project you've done in the past and then edit it from there, whatever the case, you're going to want a standalone project or file, if you will, that you're going to use to write your logic and to test your logic. Okay, once you've done that, you're going to create a list of variables. What were the inputs to the function blocks, or what are they going to be? What are the outputs from the function block? And then what are the lists of the variables that are used internally by the function block? That's all information you need to know as you're creating them. Now, once you've done that, you need to go to the Cscape Navigator and then add a new user-defined function block and give it a name. Then, in the program variable window, you're going to add variables to a new section that was created in the variable window when you added and named the new UDFB. And all the variables that are used by the UDFB you've created have to be listed in that section of the program variable window. Now that you've created the block and named it, now that you've added the variables to the program variable window, now you need to replicate the program that you basically created and tested in your standalone project. You're going to want to replicate that logic in the UDFB block itself, in the area allocated for its logic. Once that's complete, then you're going to export that UDFB as an independent file. It has a file extension of CPU. And then following that, you're going to go ahead and, using another Cscape program, you're going to import that UDFB so that you can test it, preferably with multiple instances of that same function block. So that's the basic approach you're going to take for any UDFB. Now, yes, there's lots of steps, but again, we need to stress the benefits are many. Now I want to talk about my workflow that I use when I'm creating more complex UDFBs. And this is just one way to do it, but it's based on experience I've had and mistakes I've made, and also mistakes I've seen students make as well. Okay, so you're going to start with a brand new program, or that's what I do anyway. Start with a brand new program, and I create a standalone program that contains the logic that ultimately is going to be the UDFB. And then I not only write that logic, of course, but I thoroughly test it. Once I'm done with that and I'm satisfied with the way things work, then I create a brand new Cscape program or project that the purpose of this new project is going to be for the creation of the UDFB itself. And the steps involved there are to add and name the UDFB from the Project Navigator, to basically copy and add the variables to the program variable window, but this time, because there's a lot of logic involved, I'm going to use the Edit Variables as Text feature in the program variable window to be more efficient and to ensure accuracy. Next, I'm going to go back to my original program where I created the logic, and I'm going to copy and paste that logic back into my new project into the UDFB section. Now, after I've done that pasting, all the variable names in the logic need to be replaced with variable names that are appropriate for the user-defined function block. And in a minute, I'm going to show you a slide which kind of illustrates the differences between variable names in your main loop or in a subroutine and variable names in a UDFB. So once you've gone through and you've set all the variable names to appropriate, then you're going to perform an error check, because there's plenty of room for errors at this stage. So you want to make sure that you've eliminated those. So you do the error check just to make sure you didn't make any mistakes. And then finally, you're going to export the UDFB to a CPU file. And when you do that, you're going to have the option between a protected file and an unprotected file. Now, even if ultimately you plan on deploying a protected file that hides all the secret sauce from your customers, you're going to want to start with an unprotected file until you're 100% certain that everything is working the way you want. And after exporting that unprotected file, you have a third program that you're going to use to import the UDFB you've just created and test it using multiple instances. Now, in many cases, this third program is a program you were working on when you realize that, hey, this function is done repeatedly, I should create a UDFB for that. And so that may be a real project that you're going to ultimately use the UDFB on. So that's my workflow for creating a more complex UDFB. And don't worry, we're going to demonstrate all of this stuff. Okay, I just wanted to put all these steps on a single slide so you could freeze frame and use those for reference. Now let's talk about an important topic, if you will, and that is UDFB variable names. How do UDFB variable names differ from the simple variable names that might be present in your main logic block or in a subroutine? Well, on the left there, I've got a snippet of logic using simple variable names that you might find in a main loop logic block or in a subroutine, just with simple names. Now, that exact same logic with those same variables, to be properly named in a UDFB, needs to have the prefix, or as a prefix, the name of the UDFB before the variable name. So enable becomes average underscore scale dot enable in the example where the name of the UDFB is average underscore scale. So that's critical, because at some stage in the process, you may paste all the data in or all the logic into your UDFB area, and you may think, oh, I'm done. But the reality is you've got to go through and do that renaming, and you don't want to forget that step. So now we get to the part where we do the real work here, and that is I demonstrate all this for you so to really hammer it home. Let's start out in Cscape, and I'm going to go ahead and show you program one, if you will. This is the program that I use, which is a standalone program that I use to develop some code and test some code that I'm going to utilize for scaling and averaging analog inputs. So it's pretty common in applications out there where you're going to have analog inputs, whether you're measuring level or temperature or pressure or whatever the case may be. And you may want to apply some averaging or some other type of logic to kind of get those values as stable and as responsive as you need them to be. So what I've done here is I've created some logic which can average together up to 100 analog readings as they come in every scan, and then also scale those to engineering units. So that's what my logic does here. And it's a fairly significant amount of logic. There's about 40 lines of code to do this efficiently and safely. Now, there's different ways that this could be done. This is just the way that I chose to create this logic. And I'm just going to quickly go through what this logic is doing, just so you have a better understanding, and then we'll get into the steps required to take this logic and turn it into a UDFB. The first part of my logic is all about what we're going to do before we start averaging. I've decided to include a bit type variable or Boolean type variable called enable. And when this variable is off, then we're not doing any averaging at all inside the function block. We're just passing the input straight on through to the output. When that enable variable is a 1 or is on, then we're doing the actual averaging of the analog signal. And in either case, whether it's enabled or not, we are doing scaling between the raw input and the engineering units that we want the value to ultimately be in. So I'm just going to quickly go through this logic here. So in the first rung, all we're doing is ensuring that the person who uses the UDFB gives us a value that's appropriate. So we're going to give them the capability in this block to average anywhere between 2 and 100 samples. If they put something in outside of that range, we're going to set it to a default of 10 samples to be averaged. We need to create a real variable from the number of samples that is provided as an input to the function block, because that's an integer, and when we do a calculation on the average, we're going to use floating point math, and we need a floating point version of that same variable that was an input or will become an input to the function block. Also, before we've enabled averaging to happen, we need to zero out a bunch of math registers, or a bunch of math variables, I should say, so that we're prepared as soon as that enable turns on to effectively do the averaging. And then once again, if we're not in the active or enabled mode, we're just passing our raw analog input straight across to the averaged value, which is one of the outputs of the function block. That's the first part of the logic. And then the rest of the logic is all about what happens when we actually do have the enable bit on, which once again is one of the inputs to the user-defined function block. Okay, so we're setting up a shift register of 100 values because we may need to average together as many as 100 values. Also, we're copying our new analog to digital conversion, which we call raw in. We're copying that over, converting it to floating point, and copying it, or I should say adding it to a sum, and that's the sum that we're going to use as part of our averaging calculation. Before our shift register becomes full, to calculate the average, we're basically going to take our sum and divide it by the number of samples so far, and then once the shift register is full, then every time we add a new value, we need to subtract off an old one before we do the math to calculate the average. Because, for instance, if we're averaging 100 readings, we want to throw away the 101st reading, so we need to subtract that one off from the sum and then go ahead and calculate the average. And then at the end, we just have a couple rungs to perform the scaling that we want to do on the averaged result. And then we just have a simple rung here that determines or flags whenever we've filled up our shift register with the number of readings that we're going to average together. That's the logic I've created. Now I want to turn that into a user-defined function block. Now for the next part of my demo, instead of going through and doing this 100% live, because there is some repetition involved, I went ahead and pre-recorded that portion of the demo so I could speed up the video to show some of the repetitive parts in a much quicker fashion. So I'm going to go ahead and show you that next part of the video next. So remember, what we've done so far is we've created the logic in a standalone program and we've thoroughly tested. Now before I start that next part of the video, let me just show you that I have indeed tested it. So let me go ahead and switch to my overhead camera here. And here you can see just a test screen that I have to be able to test my logic in the standalone program. So here's my raw analog input coming in on the left here. I've set the number of samples to average at 100. Here's my scaling coming in, here's my scaling going out, and here's my average and scaled value. Now, I've not enabled the averaging feature yet, so therefore that's why my input is being passed directly to my output. Now I'm still scaling, but you can see that value is jumping around quite a bit. So when I go ahead and enable, you can see that really stabilizes things significantly, including on the scaled output where that's pretty much rock solid at this point. So no question that the logic we've written, and I've done a lot of additional testing as well, that is doing exactly what we want it to do. So I've written and I've tested the logic, and now the next step is going to be turning that into UDFB, I should say. So let's go ahead and start the next part of the demo. Now that this has been created and tested, I'm going to create a new program for the purposes of creating the UDFB. So it's a variable-based program. I'm going to go ahead and, now that it's created, now I'm going to follow the process of creating a UDFB. How do I do that? Well, I start down here in the UDFB section by adding a UDFB here and giving it a name. Now the name I want to give it is average scale. So that's the name I'm going to provide it with. Next, I need to add the variables to my program variable window for this new UDFB I've created. And if we go in here to the variable window, we'll notice that in addition to all the standard default variables that are in here, there's also a new section for the UDFB variables itself. So when I add the variables for the UDFB, I add them here. And I can use my insert key to do that. So let's just go ahead and add an input, an output, and a private variable here. So on the input side, one of the variables that we have, and I want to use the same variable names that I used in my other program, the one I used to develop the logic. So we had an enable bit as an input, and it was truly Boolean. And then on the output side, we had one called average, which was a real. And then an internal private variable we had, just an example of one we had, was called sample, and it was an integer-based array of 101, and I'll stretch this out so we can see it better, of 101 samples. Now, the 101st, the last member of the array, we just used as the output for the shift register we had. So that's why I've sized it as 101 instead of 100. These are example input, output, and internal variables. Now, why am I only showing you examples here? Well, because of the fact that there's quite a few variables. Instead of adding them all in manually, what I'm going to do is I'm going to use edit variables as text to actually do this more efficiently. So I'm going to go ahead and highlight average scale, right click, and say edit variables as text. And you can see here's the list of my input, output, and just internal variables. I added one of each there so I could see the format. Next, what I'm going to do is go back up to the original program, and under main, under the global variables, and the reason I'm doing global is because that's where I added all my variables for the logic that I tested. So I'm going to right click and hit edit variables as text here as well. And then I can scroll down. Let me move this out of the way. I can scroll down and easily copy all the variables that were associated with the logic that I wrote that ultimately I'm turning into a UDFB. And that's one of the benefits of using a dedicated program to house all that logic that you're creating. It's because it's very easy to copy the variables that are used in that program because they're all pretty much right there together. And that's also the reason I used global variables for everything in this logic that I created and tested, again, to keep all the variables in one place that I could easily copy. So I've highlighted them all. I'm going to hit copy. Now I'm going to go back again to my other program and go ahead and go back to my edit variables as text section here. Okay, and I'm going to go ahead and just at the bottom here, I'm just going to paste in with a Control V. I'm just going to paste in all these variables here. I've already taken care of enable. That was an input, right? So I can go ahead and delete that. Another variable that's an input is raw in. Now this one was tagged to AI1 because I used that when I was testing. Now in your UDFB logic, you're not going to be tagging these variables. So I'm going to go ahead and get rid of the tag portion or the mapping portion of that for that variable, and I'm just going to copy that as, and I'll use a Control X and then Control V to add it where I want it as an input. Samples is also an input, as is raw min, raw max. scaled min, scaled max. So those are all inputs. So instead of doing them one at a time, I'm going to go ahead and copy them in one fell swoop. From an output standpoint, I've already taken care of average, so there's no need to duplicate that. And the only other output I have is scaled, so I'll move that to the appropriate place in my variable list. And then the rest of these variables, and again, we've already taken care of this one. The rest of these variables are internal variables or private variables. So I'll move those to the appropriate location. And now I've got all my variables created, and that was a lot quicker, and I'm ensuring that I'm using exactly the same names. So I'm going to go ahead and hit this X here. It's going to ask me if I want to save the changes. I say yes. Okay, and now if I go in and take a look at the variables, there they are. They're all there. The inputs, the outputs, and then the privates, which don't have any designation here. Okay, so I've successfully added all my variables. The next thing I need to do is copy over the logic into my UDFB block. So I'm going to go back to my main program here where I created the UDFB. And I'm going to take a look at how much logic we're talking about here. If I scroll down, I'm going to see we've got about 43 lines of code. So I'm going to go ahead and do a Control A to select everything and a Control C to copy. Now I'm going to go back to my new program and into the, not into the main loop, but into the average scale UDFB section. And the reason I noticed, or I checked to see how much code I was going to be pasting in, is so I could know how much open space I needed to add here. So I need to add about 40 lines of open space. So I'm going to insert 20 lines here, insert another 20 lines here, and then I'm going to go ahead and do my paste and paste it in there. And we'll scroll down to make sure everything pasted in okay. It did. Okay, that looks good. Now, you might think we're done, but we're not. Remember, the variables I just pasted in are not the right variable names. They don't have the prefix for the UDFB name. So we need to go through now and replace all these variable names with the appropriate variable names. And I'm going to show you a couple tricks for doing that. So one way we can do that is we can just go in and we can browse our tag list and replace them one by one. So let me go ahead and hit the Browse Tag button here. And every variable we want to fill in here is going to be in this category underneath the average scale list here. So this is the one I want to select. Hit OK, and there we go. There's our prefix that has been added to that variable name. We'll do the same thing here. Again, browsing for the right tag that matches what we're replacing. We'll do the same thing here. Again, this is the browsing approach. And this is a great approach to use for smaller UDFBs because you can just quickly get to them and you're good to go. But the problem is we've got literally a bunch of these to do, and that's going to be fairly time consuming. So one of the things we can do is we can just go ahead and manually add the prefix average underscore scale dot to all these variables. So I'm copying this section of text, and next I'm going to go ahead in on every variable, position my mouse, and hit Control V to add that in. Now you'll say, wow, that's a little bit tedious. It is, but keep in mind this is work you're going to be doing that ultimately is going to save you a bunch of time because you're going to be using this logic over and over again in your program, or not in just this program, but you're going to be using it in all kinds of projects to come. That's the whole point of creating user-defined function blocks. One thing I do want to mention is this. An advantage of creating a brand new program to use when you're doing the UDFB is that all these variables I'm replacing technically aren't even on the variable list that's in my program variable window for this project. So if I forget, as I'm editing, if I forget to put a prefix in for one of the variables, I'm going to get prompted and it's going to say, hey, do you want to create a new variable? Because it's going to see the one that I forgot to replace as a new variable. So I'm going to do that intentionally here. I'm going to forget to type in the prefix or to add the prefix to this, and it's going to ask me, hey, average does not exist. Do you want to create the variable? And that's a clue to me that, oops, I made a mistake. No, I don't want to do that. Instead, what I want to do is I want to add in the prefix that I forgot to add in here. So I'm just going to go ahead and add all these in here, and we'll speed through the process. Now notice you don't have to change the always on contact. It's fine just the way it is. So that was a little tedious, no question, but again, it's all worth it in the end. So sometimes the next thing I'll do is I'll go through here, and if I need to, I'll stretch some things out a little bit that might not be as readable as I'd like, because remember, these names are much longer than they were before. So there's an example of one here. So I stretched that out a little bit. And I intentionally used relatively short variable names when I created this code originally, because I knew they'd have this long prefix on the front of it. So the next thing I want to do is I want to do an error check to see if I have any errors, and we'll see what happens here. So I did have an error. That's important. Okay, let's go fix that. On rung 5, it looks like I forgot one. The other thing is just a warning. So let's go to rung 5, and let's see what we find here. Rung 5, yep, that enable, I never changed it. I missed one. It's still got the old name. This is another advantage of not starting with the original program to create your UDFB, because in the original program this wouldn't be an error. It would say, oh, that variable exists in my program variable table, so it's not an error. In this case, we do have an error. So I need to add my prefix here, and it's no longer on my average scale dot enable. There we go. There we go. So it wasn't on my copy buffer. Let's do another error check, and we should only get a warning that we haven't created any screens, but we don't want to create any screens, so that's okay. So we're good. All right, so our UDFB is created. Now let's go ahead and save this project. Well, I'll do that later. First, let's go ahead and export this UDFB. Let's go ahead and export. Would you like to export the module as fully protected? In this case, I don't. I'm going to say no. Now, of course, fully protected means that you can't see any of the logic inside of there, which is important if you're going to be sharing a UDFB ultimately with a customer and you don't want them to see the secret sauce inside the UDFB. However, if it's for your own internal use, you definitely don't want to protect it. And later you can always create a protected version, but you always want to at least create one unprotected version of the UDFB before you create a protected version. So would you like to export the module as fully protected? I say no, and I'm going to go ahead and give it a name. Okay, average scale. It tells me it already exists. I'm not going to overwrite the one I created before, so I'm just going to say no here. Normally I would just complete this process. So we've gotten almost all the way through the process of creating a UDFB. In reality, we have created the UDFB. Now we just need to, in another program, we need to import that UDFB and test it using multiple instances if possible. I'm going to go ahead and fire up Cscape again. And this is a new program. It's actually the program, I guess you could say, that inspired creation of the UDFB to begin with, because it was a program where it became obvious that some analog averaging would be valuable. And let's go ahead and do scaling at the same time while we're at it. So let me show you kind of one of the screens that we're looking at here. This is just an example for doing like a water heater control. And we've got a couple of analog channels that could use some averaging and some scaling. Now in a real application, heck, you might have 8 or 10 or 12 or even more. analog channels that you'd like to average at different rates, because you might have some signals you want to be real responsive and other ones that you need a lot of averaging because they're not changing quickly anyway. Let's go ahead and finish the process by importing in that UDFB we created. So we go up here under Logic Modules and we hit Import Logic Module. Now we need to import that CPU file we created. So there it is, average scale.cpu. And now we're looking at the unprotected code inside of the UDFB. Again, because it was unprotected, it's not being hidden from us. But to actually utilize this code, we need to go into our main loop and then add a couple instances of these UDFBs to our logic. So if we look over here in our project toolbox, we can now see that we have a new section called UDFBs, and our average scale block is available for us to use. So I'll go ahead and drop it there. Now, because you can have multiple instances of these UDFBs, you need to give each instance a name. So in this case, we've got level and we've got temperature that we're going to utilize this for. So let's go ahead and create an instance called level, and then up pops a dialog with all the different variables we need to fill in. We have all these inputs and we have all these outputs. So I've already created the enable input, so there's level enable. The raw input is going to be the variable that's tied to the analog input channel, so that would be level raw in this case. And it happens, you can't see this, but if we looked in the program variable window, you would see that this was memory mapped to %AI1, which is how this variable is linked directly to that analog input. Now, everything doesn't have to be a variable. So the number of samples that I want to average here, let's say, is 100. My minimum value on my raw side is going to be between 0 and 32,000. And the scaled side, let's say, is between 0 and 100%. And remember, this is a floating point value we're creating here. And then my output variable for the average of my raw value is called level averaged, and the scaled version is called level scaled. And now I've created my function block. I do need to connect it up to the rail here, and I can't do that directly. Just like every other function block, I do need to have an always on contact here. Now I'll go ahead and connect it. Now you might think that, hey, I'll just copy and paste this for my next instance. That doesn't work. So what you'll need to do instead is just manually put the instance in, okay, which isn't that big a deal. I'll start with the normally, well, if I can spell right, I'll start with the normally open always on, add another instance here, and this time I'll repeat what I just did, but this time we're going to do it for our temperature analog, and I'll just call this temperature. And then similarly, I'll fill in the information. So here's my temperature enable bit. I need to have a variable tied to the temperature, that is a raw, and this one happens to be mapped to %AI2 because that's where the temperature input's coming in from. Again, I'm going to do 100 samples. I could do 50 or 30 or 20 if that was more appropriate. Again, my raw is coming in 0 to 32,000. My scaled side, let's say, is -50 to +250C. Maybe this is a temperature transmitter, and that's the output from my temperature transmitter from an engineering unit standpoint. And then the average is in a value called temperature, in a variable called temperature averaged, and the scaled is in a variable called temperature scaled. So let's go ahead and do a quick error check and make sure we haven't made any mistakes here. Everything looks good, terrific, not bad for a live demo, except for my lousy typing at times. So this is where I would normally do the download, and then we would test it from here. Now, because you were watching the first part of the demo and I was sitting here idle because I recorded it earlier this morning, I went ahead and downloaded this program already. So let's go ahead and take a look at it. Here we go. Here's our application, and you can see we've got our level and our temperature. Now I have not enabled the averaging yet, even though we're still scaling. We always scale whether we're averaging or not. And then when I hit enable here, you can see that the values really solidify. Still a little bit of twiddling on the temperature, but not much. And even as I scale the values down with my simulator here, or down or up, whatever the case may be, they're nice and stable based on the averaging that we have performed. That pretty much covers the material that I wanted to cover with you today. Again, if you have any questions and you're watching this live, you still have a couple of minutes to get those questions into the chat section. If you're watching this on replay, you have plenty of time to get your question to the comment section. All right, and we'll get those answered quickly in either case. I do want to mention that we have a technical session every Tuesday at 2 o'clock. Whether it's fully live and we're answering questions live, or we're streaming a pre-recorded video and answering questions live, we're always here Tuesday at 2 o'clock. If you haven't already, I would encourage you to subscribe. Of course, it doesn't cost anything. And if you choose notifications, you'll be notified every time we go live or every time we add a new video. And remember, like last week, we added several new videos, each short ones, because every day we had a report from the Automate trade show. So there's some benefit to doing the notification. And we've looked at the statistics. Almost none of you do notifications. I think you're worried about us maybe bugging you or something, or maybe YouTube bugging you, but I don't think it's a big issue. But anyway, we do ask, if you haven't done so already, to go ahead and subscribe. In terms of the rest of the videos for this month and moving forward, you should know that we haven't quite set the topics yet for the rest of this month. Rest assured, we'll be here this upcoming Tuesday. I've got a couple topics I'm reviewing, but any day now we'll have that topic posted on our website, and we'll have a thumbnail posted on YouTube as well. So once again, this is Chuck Ridgway, Automation Technology Manager at Horner. I'm just signing out from our Tuesday live stream, and I look forward to seeing you next Tuesday, and stay safe out there.